In the previous modules of this course, we have discussed various kinds of game representations and their equilibrium notions. So before proceeding further, let us look at one real-world examples where this kind of a game theoretic notions are being used in practice. And this is in the context of peer-to-peer file sharing. So these slides are actually adapted from a similar course at Harvard University. So what is peer-to-peer? You know that there are several devices which can share large files. Instead of loading one particular server in the traditional mode, which is shown on the left hand side, your download rate may go down when you have large number of users. On the other hand, when you have peer-to-peer, because there is no single server from which you are downloading this content, the download rate remains almost same. So every individual or every machine in this peer-to-peer system is a server and also a client at the same time. So in this setup, there are certain desirable properties. So why do people actually use peer-to-peer systems is because of its scalability and also its failure resilience. Scalability, as we have seen in the previous graph, that it keeps the download rate almost same for a large number of users. And even if some of these peers actually stop sharing the file, the download process will not be impacted because there are several other peers which also have copies of that file. So in this context, we'll be using this terminology of protocol, which means that which kind of messages are being sent in a P2P system, action and the actions that can be taken. Client is a process of sending messages or taking actions. A reference client is a distinguished client which uses a specific implementation, and peer is the node, or in the context of game theory, they are the agents who are could potentially behave strategically. So what are some of the early peer-to-peer technologies? So Napster is one of the first P2P technology, which actually started in 1999 and closed down within 2 years. They had a centralized database of all the peer-to-peer systems, and they were typically used to download music from one another. Nutella is the other one, which is still functioning. So there is no centralized server kind of a setup. It gets the list of IP addresses of peers from the set of known peers. Now, to get a file in this setup, a query message needs to be broadcast by a peer to its known peers, and the query response, it will send back. So some other peer B will send back a response if it has the desired file. It will be routed back to the requester, and then A can directly download that content from B. So this is the Nutella framework. Now, in this context, everything is so the whole file is getting downloaded in one go. So whenever you know that someone else has this, some other peer has this particular file, the whole point of this exercise is to find out who has that file, and then this protocol will directly download the whole file from that peer. Now, if you look at the file sharing process from the lens of game theory, so let's consider for simplicity there are only two players. One of this, so both these players have two strategies, either to share or free write. So in the share mode, they actually allow other people to also download the content, which actually requires some amount of upload bandwidth being eaten up. Alternatively, they can just free write. They can just shut down all kind of uploading links, and they can only get the file from the other individuals. So in the context of P2P, in the terminology of P2P, this sharing is called the seeder, and free riding are called the leechers. The people who download, they are the leechers. The people who share, they are the seeders. Now, you can see that when both these individuals are sharing, so of course they get some amount of payoff, and this is going to be symmetric. But if one individual shares, the other individual free rides, then the sharing, so we will consider that the player who is sharing is actually getting a lower payoff because it is uploading, so therefore its own bandwidth is being eaten up, but it is not getting in return the desired file it liked. On the other hand, free rider actually gets both, because it gets what file it wants to download, and that also happens in a faster rate because it does not have anything to upload. So therefore the free rider is always in a better position when the other player is sharing. And the symmetrically opposite thing happens when the roles of these players are changed. And if both try to free ride, nobody uploads anything, they both get zero payoff. Now you can see that this is the setup is very similar to the neighboring kingdoms dilemma, if you recall. So you can see that the free riding is a dominant strategy in this case for both these players. So therefore everybody should try to free ride, because that is the most rational thing to do in the file sharing game. Now this is not only a kind of a theoretical idea, I mean it has been observed through real experiences. So almost out of 33,000 hosts, this experiment actually shows that a very little proportion of the peers actually share the files, and the people who share, they share it in huge numbers, but this curve sharply falls down, and majority of the population, almost 2/3 of the population, do not share anything. They only free ride on the others. Now you might think of that the clients, so this is all software based, right? So you can write a client for the peer-to-peer system which ensures that everybody should upload. They cannot choke the uploading streams, but that is not possible because there could be a competition among the developers of these clients. And so some clients would give you a better flexibility of controlling this upload speed, and therefore that client will be preferred more by the people who want to free ride. So this phenomena has been extensively observed. So almost 85% of the peers free riding in 2005. These are all data from surveys and experiments. Nutella actually, because of this reason that it sends the whole file and it does not care about the strategic behavior by the free riders, it has less than 1% of worldwide P2P traffic by the year 2013. So there are other P2P systems, they also made the same fate. Now the protocol that we are going to discuss in quite some detail is this Bittorrent protocol. This is actually used most in the traffic in US and elsewhere. So they also they are also used for software distribution, something like the open source software distribution. They are also shared on this P2P protocol. So what is this? What is Bittorrent, which is so attractive for the people? So the key innovation is that they do not share the whole file in one go. Typically, peer-to-peer file sharing is used for large files. Therefore, it is meaningful to break them into very small pieces, and that also gives rise to something like a repeated game. So, and the principle of that repeated game is that if you let me download, then I will reciprocate. So let us look at what are the schematics. So this image is actually taken from the Parks and Sipen, the two instructors at Harvard from which these slides are adapted. So in the Bittorrent world, so there are some directories, some web-based directories where the certain links for certain peer-to-peer files are given, and these files are so the information about these files are put in some special kind of files called the torrent file. It essentially contains all the metadata of that file. In particular, one of this information is the tracker URL. So you go to that. So whenever you open the torrent file with the corresponding torrent client, it has the URL which is of that tracker. So tracker is someone like who is the central planner who is actually coordinating the whole peer-to-peer process. The tracker has a list of all the peers with their IP addresses and ports from which you can download these files. And once you are connected with this with the tracker and the list of peers, you can find out whichever peer is more convenient, maybe geographically closer to you, and you can start downloading from that peer. Now, Bittorrent uses an optimistic unchoking algorithm. Let us first discuss what is this algorithm and appreciate the positive points and also point out what are the limitations of it. So the reference client, let's say the Bittorrent client here follows the following protocol. It sets a threshold level of R for an uploading speed. So typically this is the third maximum speed in the recent past for that tracker. So this that particular threshold. Now, if a peer J is uploading to some other peer I at a rate more than that threshold level, then this reference client will unchoke that J. So it will allow that particular peer to download content from other peers. But if it is uploading, so if the upload rate is below that threshold, then it will be choking that thing. So it will not allow that to download the content that it is looking for from other users. So in some sense, it is kind of doing a tit for tat protocol. So the moment you are uploading at a higher rate, will also allow you to download at a higher rate. But if you are not allowing people to download, so you are not uploading, then you will be choked. But it also uses this optimistic unchoking. So for instance, if a node or a peer has just entered this scenario, then how it gets started? This particular protocol will have a starting problem. So in order to circumvent that problem, it optimistically unchokes a random peer from this neighborhood who is currently choked, and leave that peer unchoked for 3 time periods. So, so using this optimistic unchoking, the users will typically start downloading these files, and whenever they have certain content with them, then they will come back to the scenario where they are also uploading at a higher rate. So this is actually forcing this repeated game by fragmenting the file, and the Cedar-Licher game is a repeated prisoner's dilemma or neighboring kingdom's dilemma game. And the strategy for the Cedar, which is a known protocol for repeated prisoner's dilemma, is the tit for tat. So tit for tat protocol essentially follows the same thing. So in the prisoner's dilemma, you have two strategies, either to cooperate or to defect. And if you are caught that you are defecting, then in the next round the other player also reciprocate with defecting. But if you are cooperating, if you come back to your cooperate state, then the other player will also cooperate. So this is exactly the tit for tat strategy, and that is exactly what is happening in the Bittorrent client. So let me show you an illustration using an animation here. So this animation is showing a bunch of peers. Some of them are Cedars, some of them are just Lichers. In this case, this 2 on the right hand side are actually the nodes who started it. So whenever when you observe this, initially it is starting with this smaller bursts because it is doing this optimistic unchoking. And now you can see that whenever some of these nodes have actually received some of those pieces, it has also started sending packets to the other peers. Right. So after a while, you'll see that this optimistic unchoking is actually allowing each of these nodes to start downloading from its peers. So let us move on to our presentation and let this animation get over. What can be some potential strategic behaviors even in this Bittorrent world? Of course, Bittorrent solves one of the very fundamental problems, but it still is not without flaws. There are certain aspects which can be exploited by a strategic agent. So one of them is how often to contact the tracker. So if you contact the tracker too often, then you can possibly get a list of new peers, and you can request them and in some sense exploit their optimistic unchoking thing. That is one way. And also which pieces to reveal. So if there are some very desirable piece of the whole file which is very much sought after, then possibly revealing that, by revealing that you can get a lot of traffic towards you. And then how many upload slots, which peer to unchoke, and at what speed, etc. We'll see some of this. So there are certain ways how you can game the BitTorrent system, and the examples that I'm going to give you are essentially exploiting one or more of those weak points of BitTorrent. So the first thing is the first client is BitThief. The goal is as usual, download files without uploading, and it is actually going to keep asking the peers for new for trackers, and it will quickly grow its neighborhood, and it will exploit its optimistic unchoking part, because if you have lots of peers around you, the probability that you will get your file just by optimistic unchoking is very large, and therefore you do not need to upload anything. Now this can be fixed to a certain extent. So you can modify the tracker. If you are getting the requests of new peers from a peer within 30 minutes, then you will block that IP address for a while, and therefore within that time period the peer won't be able to contact the tracker again. The second one is the strategic piece revealer. So consider the following strategy by one of the peers, which let's say sorts all the pieces that it has from the most common to the most rare. So, and whenever it is actually revealing the piece that it has, it only shows the most common piece that the reciprocating peer does not have, and it requests the rarest files. So in that case, what will happen is the reference client is not doing any kind of strategic manipulation. So in that case, this particular client will get the more rare pieces of the file, and it will also share the files, the pieces of the file which is the most common. So the manipulation happens in the following way. Whenever it is requesting a file, it requests the most rare one, which it does not have, and reveals only the most common pieces that the reciprocating peer does not have. So therefore it can always keep the other players interested, all the other neighbors interested in its file, because it has the more rare pieces. But whenever it is showing, it is showing the most common pieces, and therefore it is never unchoked, because it is always sharing to something, but sharing something which has very less demand. Right, so that is one way of strategically manipulating, because you will never be unchoked, because you have lots of files which the other people are actually looking for. But that is one way of manipulating and getting your files downloaded. And if you do this strategic piece revealing, the studies have actually shown that you get almost 12% less time than the system which does not use this protocol. So all in all, we have actually demonstrated that why we actually need to understand these game theoretic techniques in the context of computer systems, and peer-to-peer is one such example. Early systems were easily manipulated because they were not taking care of these aspects, this strategic manipulation aspect. BitTorrent's innovation was to break these files into pieces and enabling tit-for-tat strategy, which has actually worked very well. It still has some vulnerabilities, but it is generally a very successful example of incentive-based protocol design.